Okay, so we are going to cover about the stack data structure. Okay, so far we have seen arrays, we have seen linked list. Arrays is used mostly in the case when we want very fast, index-based query. The elements in the array are very contiguous to each other, right? That was the beauty about the array. But one of the biggest limitation of the array was that since the elements are all at a contiguous location, if my memory is fragmented, I cannot use array in that case, right? So to solve that, the linked list came into the picture, in which they don't need to store the element contiguous to each other. They can also be used in a fragmented memory. But how they do it is that each node has a pointer to the next node, and this is what the linked list used to solve those problems which the array was having, right? But then what was the need of the stack? Stack is also a kind of a linear data structure, just like stack, just like arrays and the queue. Stack also is a linear data structures which store elements one after the another. But again, the purpose of a stack is totally specific, it's different. The purpose of the stack is that whenever you have to take out the element, or whenever you have to operate on the data in a data structure in one particular fashion, and that fashion is known as the first in last out or last in first out. Okay? The example may be, for example, if you go to a restaurant, and there you might have seen the waiters piling up the plates one over the another, right? So whatever the plate which was kept last, that will be the one which will be taken up by a customer on the restaurant first time, right? So this is a example, a real life example of how the stack looks like. So this is about the stack. This is the high level meaning of the stack. Can you guys think of anything other than that where the stack can be implemented, or that the areas where the stack is being used?
So in recursion,
In recursion, very nice. So one of the application of the stack is in the recursion. Anything else?
Or undo redo functionality.
Very nice. In the undo and redo. Anything else? Anywhere else that we use stack? One very common use case, I think every day we use as a developer that tool to build our applications, and in that it is being used.
Browser.
To some extent, yes. To some extent, yes. Because in the browser, if you close the tab and then you again want to open that tab, so again that has to be stored in a stack data structure. So we use it. Another thing is that code editors. Okay, in the code editors, there's a very heavy use of stack. That is one of the few of the use cases where the stacks are being used. Now, just like linked list has few terminologies, right? So LinkedIn has a terminology like head, it has a tail. Stack also has a terminology, something called push, and there's something called pop. I know this you guys should be already knowing, right? But just for the sake of the completion of the topic, I'm just mentioning the terms, right? So push, whenever so push is just nothing but like adding the data, and pop is nothing but removing the data. And there's another term called peek, which is just looking at the top. Whenever we have to add data, we don't normally call it like add data or insert data. We normally will say that we are pushing the data. Okay. And in a stack, whenever we are taking out the data, we'll never say that we are removing our data or taking out the data. Rather, we'll say we are popping out the data. Okay. At the same time, when I'm trying to look at like what is the top, what is the last element which was added in the stack, if I just want to see that, I don't want to remove it, I don't say that I want to look up, I rather say that I want to peek it, right? So these are the basic terminologies that we normally follow. Now, if there is a push operation and there's underlying implementation of stack, its time complexity will always be a constant. Pop also has a constant time complexity. The peek also has a constant time complexity, right? So whenever somebody say that I'm trying to push an element into a stack, irrespective of how it has been implemented, right, the client can believe that okay, the time complexity of the push must have been constant. Similarly, if somebody say that I'm trying to pop one element from a stack, even if I don't know what the underlying implementation of a stack is, the contract is that the pop operation should always be a constant. And similarly with the peek also. So even if I don't know what the underlying implementation of the stack is, but if I'm saying that I'm using a peek in a stack, I can take it for granted that it must be a constant operation. So now comes the implementation of stack. So the stack should have a functionality called push, in which I should be able to put the data, and it has a functionality called pop, which will return the data, and it has a functionality called peek. So stack is a data structure, and I have to implement it. And how do I implement it? I implement it using my old existing data structure, right? So in this, let's try to see if I have to use an array, how can I implement a stack? So suppose this is an array. Index is 1, 2, 3, 4, 5, 6. Size of the array is 7. Okay, and basically I have two operations, pop and push. Okay, suppose initially the first time I am pushing say 1. So as soon as I pushed 1, I go and store 1 here. Then I push 2 again, so I put 2 here. Then I push 3 again, I put 3 here. Okay, and then I have to pop. So I first time I call pop again. Okay, this 3 should come out. So this will result into the 3. So now this place has become blank now. Okay, this is not, the 3 is no more available in the array. Then and I again call a pop now. So now 2 will come out from here, and this space will again get clear, right? So similarly, what I'm seeing is that when if I'm using array as a data structure to implement push and the pop, both the push operation and both the pop operation are happening on the same side of the array, right? So let's try to see the code of it, that how we can write the code and implement this. So again, everything in the Java is a class. So I'll try to implement in the Java, which is common for everyone, and you guys can feel free to convert into the language of your choice. Okay. So I define a class called stack, and then underlying data structure that I want to use to store the stack is array. So I define something called int array, and then I define something called capacity. So I have to define what is the capacity of the state, what is the maximum element that it can store, and I also need to store what is the current index of the element where it is getting inserted. So I define a constructor here. And then let's try to define the method. But before that, let me define few helper method like public, boolean. What should I write inside this? When will I say that my stack is empty? What should I write inside this, guys? Help me with the code.
A few moments later.
See, what I'm doing is that index is -1 in the beginning, right? So what I'm saying is that I'm using an array to indicate to store the elements in the stack. Okay, this is my index that I am using to track it, right? The first element will go into the 0 position, second 1, 2. To start with, the value of I in the beginning is -1. So if the value of I is not equal to -1, it means that there is some element in the array. What will be the time complexity of this one?
We go of 1.
It should be a constant time, right? We are not doing anything. We are just checking whether the index value is equal to -1 or not. So it will take constant time. So the time complexity is a constant. Okay. Another method, quickly. Public boolean is. What should we write for checking if the array is if the stack is full or not? How can I say that?
If top of the array is equal to length of the array.
So for example, if I keep on filling the elements here, so suppose in this, if I suppose have filled 5, 6, 1, 7, 8, 4, and suppose 3. This is the state when I have all the elements filled, and I say that this is the full capacity, right? In this case, if I want to find the top, there's nothing called top, but there's a method called peak which you can have in the stack. So when you do a peak, it will return you 3. Now you get this, but how can you know with this that this is full?
Sir, index of the peak. I mean,
Index of the peak. Okay, index of the peak is equal to
6.
index of peak equals to 6. Then I say it is a full. Very nice. So what I can do is here, I can just do return index is equals to capacity. If this is the case, then I can say that this stack is full. So for example, in this case, capacity was equal to 7, and here the value of I is 6. So 6 is equals to 7 minus 1, and this is correct. So this is in a full state right now, right? So I say that it is a full. It is a full capacity. Perfect. So these are the auxiliary helper method. Now let's come to the main method. So public void. Tell me, what should be the first line of code that I should write inside for the push?
I will check the peak, sir, first, whether it is like completely overflow condition.
Okay, check if it's already. Now, since we guys are, a seasoned developer, everyone is having a work X, right? This is the expected thing that, whenever you are writing any method, you should definitely check for a boundary condition first. So before inserting any data into a stack, we should first check whether it's already full or not, right? So I check is, in that case, I should maybe throw some exceptions. If it is not the case, in that case, what we do?
Increment the value of I and just put the value of.
And I do index. Now push, I have to add data, right? So I do data. What should we do here? Should we do index plus plus, or should I do plus plus index equals to data? What is the correct statement in the line number 36? Either the first one or the second one. Which one should be the correct?
Second one, sir, plus plus index.
Okay. Why? What is the difference between these two?
Sir, in first case, it will increment later after just putting the value of data into that index. So in that case, let's suppose number is starting from -1. And first I have to increment the index to 0, and then I will put the value in A of 0.
Correct. Very nice. So basically, the index is holding the current position, right? Suppose this is a new array which I'm using for showing the stack. At this stage, the value of the index is equal to 1, right? So next time when I have to push, say I have to push 2, right? So basically, I have to add data here, right? So for that, I have to first increment I. So I have to first make I equals to 2. I have to store the value of data here to say like 90. So to do this, we do plus plus I means you increment first, and I plus plus it means you do and then increment. So this is the difference between these two. So I think the second one is right. Very nice. Similarly, if I have to do if I have to pop an element, what should we do in this case?
We need to check whether it's whether it's having element or not.
Very nice. Empty check. Because if there's no element, then it should throw me some error to know that there is no element. So if is empty. Now you tell me, I have to do minus minus. Should it be before index or it should be after the index? Should I write here like this or like this?
So what is data here? Why you are using data? I mean, in pop official.
Hey, sorry, I'm really sorry. Yeah, so you're right. So basically, we have to first find the value at that index. So that is why I first don't decrement it. First, I get the value at that index. And once I get the value from that index, after that, I'm decrementing the value of the index. So in this case, this will be index minus. If somebody is having any confusion, they can just play a safer role. They can do just they just do this. They can do this, and after this, x is equal to like -1, and this they can store in some value into result, and then finally they can return result. This is exactly same what we did in a single line of code. But if someone is having a confusion in that, they can definitely do this way. But I think that is a more better way is this one. Return, simply do return. Now you tell me, what is the time complexity of this push operation here?
Order of 1.
Order of 1. Why 1? Can you justify your answer? You are right, but why 1?
Sir, we are just checking the value at top, right?
Yes, because we know the index, and in the array, the beauty of the array data structure is that if I know the index, I can look up that value in a constant time. So I know what index I have to look the value. What is the time complexity of pop?
Same case here. Order of 1.
Order of 1. Okay. So this is push and this is pop. Both is order of O of 1. Okay. Cool. So now we have got a first implementation of a stack in which the underlying data structure is array. Very nice. Cool. Can you guys think of any limitation of this data structure, the implementing of the stack this way?
A few moments later.
So the stack has a fixed size, right? So size, first limitation that it has, the fixed size limit. And the second limitation is that whatever the limitations of arrays are, since the underlying data structure is array only, so the same limitation applies on the stack also. So for example, if the memory is fragmented and I cannot use array in that case, so same way this stack which is using underlying implementation of an array can also not be used. So all the limitation that an array has, the stack also get all those limitations because its underlying data structure is array, right? So first of all, let's try to sort this problem out, fixed size limitation. How can we sort it out if we still have to continue using the array?
When
So,
we are reaching near the capacity, then we can increase the capacity of the array.
yes, this makes sense. So what it means is that initially we designed one array. So we kept on pushing the elements. At that time is full is true. Now in this case, as soon as it happens, create a array, double its size. So normally we have an original array, and as soon as it is full, what I do, I create an array of the size twice of it, and I copy all this array, right? So we can do this change here. So if the array is full, instead of throwing this, what we do is that create a, and you make capacity twice, and copy elements from. Now, can you tell me if this happens, what will be the time complexity of this one, this whole process?
Order of n.
Order of
N.
right? Yes, it is obvious, right? So first of all, you have to define. So first of all, you need to have an extra space, and then one after the another, you have to iterate the previous array and put it into the new array. So this will take on your linear for loop. For loop will be needed, which is each and every element has to go 3 will go here, then 4 will come here, 5 will come here. It will take one loop, one for loop it will be needing. So that is why the time complexity of this operation will be. So now we have sorted out one challenge. Another challenge here is that the push and the pop, the contract of the stack is that the push and the pop should be constant, but at one moment of a time when the stack is going to overflow, at that time when it is trying to double its capacity, at that time the time complexity of the push operation becomes doesn't remains constant. So this is one of the biggest limits. So it leads to the performance impact of the stack, right?
Vishnu, I have one question here.
Yeah, please.
We gave this example, right? That if there is fixed size limitation, then we can increase the size, and we have doubled it.
Mhm.
But what if the stack is at a full condition and we just increment the size by 1?
So if you increment the size by 1, what will happen is that, see, what we are doing in this case, whenever we have to see the same array size cannot be incremented. This is one thing, right? So whenever you have to, increment the size of an array, always you'll have to, what you have to do, you have to create. So suppose initially my array was of size say 3. So I have element like 1, 5, and 7. Now I have to add 8 into this one. So you are saying that let's create, suppose 9. Let's create one more, another array of the size 5. So I have 7, 9, and then go and 8 into this. And again, if I have to add, let's create another one. And then say here 9. Now the problem with this approach is that, so every time when you create an array, it takes some time to initialize that array. So this is one thing. So every time if you say that, with every push, if I'm going to create an array, this will require the copying of all the data from this to this, from this to this, right? So every push operation will become order of the now n. So time complexity, which was initially order of 1, and because of this dynamic sizing intermittent, it was order of n. Now because of this approach, time complexity of the push operation will become order of n all the time. So this is one limitation. Okay. The second limitation is that every time when you are doing a push, you are creating a new array object. You are creating new array objects, right? If the rate of insertion of your data in a stack is very high, right? It's a very write intensive application. You'll end up creating so many array objects, right? That it might before for example, the different languages have a different way of handling the memory. So if I take example of Java, it's being taken care of by the garbage collector, and the garbage collector in Java reclaims the memory automatically. It is not triggered by the developer command, right? So in that case, suppose if the rate of creation of these stack object is too high, right, it might happen that it occupies the whole of the heap space, and your system can go into out of memory, reasons, out of memory space also, right? And this is known as the memory leak. And this kind of the pattern is also known as the memory leak. So with every request, if you're creating each newer objects, which you could have avoided, right? So this kind of situation, or this kind of scenario is known as a memory leak, in which you are creating more and more objects which would be avoided. Does this make sense, Paritosh?
Yes.
Whatever that I said, like I double it, is also not optimal. The reason is that suppose initially n was equal to 6. As soon as it reached, I made it n equals to 12. Here it is not a much difference. Suppose initially n is equal to say like 5,000. Okay. And when it reached 5,000 step, I made it n equals to say 10,000. And suppose after 5,000, I only had to store 100 more elements. So I had to only store 5,100 elements. So I am storing only 5,100 elements, but I have created an array of size 10,000. So it's just holding a size of 10,000 in the whole space. So that is also again a wastage of space also. Does that make sense?
Yes.
So that is, so again, this is also not a foolproof thing. This also has its limitations. So this also results in the wastage. So if we go with your approach, that will not require any wastage of effort. But at the same time, the whole purpose for which the stack is defined, in which the push should be a constant time, gets defeated. So I cannot go by this approach also, because in that case, the whole purpose of the stack itself is defeated. Because if I'm taking push operation to be linear, there's no point of using stack. I could use any other data structure and that do the same thing. I'm only using stack because I want to do push in a constant time, and I want to do a pop in a constant time. So again, I cannot do this. But at the same time, this is also not 100% foolproof. This also has few challenges. So the problem is, suppose I have a stack, and in the stack you have been told that you can only use these operations: push, pop, peek is empty. Okay, the standard method that we defined in the stack, you're only allowed to use these methods. Okay, and suppose the stack has the elements like this: 1, 7, 3, 4, and 5. What you have been told is that sort this stack using above. Right? So basically, this has to be converted into 1, 3, 4, 5, and 7. This is my input, and this is my output. Okay. Just for your reference, for a hint, so you can think around the lines of recursion, and you can think around the lines of the stack properties. Are you guys clear? What is the meaning of this question?
Yes, sir.
Cool. So, any ideas, guys?
So sir, I'm thinking I will use 3 stacks, right?
So stack 1 we have been given. Initially, stack 1 is, suppose this is like this: 3, 7, and 5.
And
This
the temp stack 2 is like empty.
temp stack is now empty.
Stack 3 is also empty.
Okay.
So firstly, what I will do, I will just pick the top value of stack 1.
Okay. So the 5 top value. Okay.
And put into like temp variable.
Into the temp variable. Okay. So
Yeah.
So you have
Then
removed
I removed 5. Now I am continuously checking by popping the next element from the S1, and if the value is greater than, then I will put that element into S2.
Okay, so the I pop.
My name is like I just want a smaller value from the S1, right? So in this case, I will get 1 in the temp value.
Okay. So what you said that first I pop the value from the stack S1, and if it is greater than 5, then I put it into the S2. This is what you said. So
7.
7 is greater than the 5, so I put 7 here, right?
Now 1 will come, but 1 is less than 5. So instead of 1, I will just put the value of 5 into the stack, and temp will be 1.
Okay, I put 5 here, and now
1.
is 1 now. Move 4.
Yeah.
So 4 is greater than 1. So I put 4 here again.
Yeah.
I put 3. 3 is also greater than 1. And now what happened to 1?
So finally, my temp value is 1. Now what I will do, I will just put the value of temp into the S3. S3, sir, not here.
Okay, you put 1 here.
Yeah. So now I get the minimum value in S3. Now my temp will be 3.
Okay. So what now I can see is that, okay, so now your temp is
3.
3. Okay.
Yeah. Now I will check with 4, like compare with 4.
Now
Now 4 is greater than. Now I will put 4 into S1.
4 will come here. And then what you will do? So 4 has been taken out. Now you take out 5. 5 is also 3.
Yeah.
5 here.
Then 7. When the S2 is empty, then I will put the value of temp into S3 again. Then 3 will come here. 1, 3.
So 1, 3.
Then I will do same operation till last. Ultimately, I will get the sorted order in S3, right?
Yes, but you are adding 2 additional stacks, so the space complexity is order of n, and it is more than order of n, basically twice n, but it's still linear, but space complexity is linear. And second, the things that you are saying, how much will be the time complexity of that case?
N square.
Right, O of n square it should be, right?
Yes, sir.
The time complexity is O of n square. Anybody else who can improve this complexity? So suppose my initial stack that has been given is like this, say 3, 4, 1, and 7, 6, something like that. What I can do is that let's try to use recursion. So in the recursion, I again repeat, in the recursion you have how many things? First thing is that you have to do what the boundary condition is. Second, you have to focus on the logic, and the third, you have to focus on the recursive call. And when you are making a recursive call, the size should be increased or the decreased based on what the situation is. These are the 3 things. And the most important thing is the 4th point, which says that I should be knowing what is the meaning of this function. Okay. Now, let's try to say that, public void sort and I'm given the stack S. Okay. First of all, the termination condition. What should be the termination condition?
Yeah, is empty.
Yes. So it should be either S is equal to null or S dot is empty. If this is either of the case, then in that case I just return, I don't do anything else. Okay. And let's try to pick the element here. Int number equals to S dot, and I call this recursively again. So, and I'll write something here, but before that, let's try to understand what is happening as of now. So if we do like this, and suppose if I have a smaller stack, let's try to take a smaller stack like this. If we do like this, right now what is happening is that the first time when I called sort as like this, the first time the value of the stack was 3, 4, 1, and in this case the number value was set as 1, right? And then again the second call of the stack happened. S now remains 3 and 4, and the value of the number comes out as equal to 4. And then next time the 3 time the stack remains 3 and number remains as 2. Fourth time when it goes, then it is empty. There is nothing inside the stack, so it returns, right? When it returns, then from the fourth it will go to the step 3, it will get to the step 2, and then we get to the step 1, and it will return. This is what is right now happening. Okay, so we have to write some logic here, logic here to reverse. Here for that, let me write a method, insert elements in order. Suppose this is a method, okay, and that takes on a stack, and that takes an element which is data, which is number. Now the function of this method insert element in order is that if it is a smaller element than all the existing elements in a stack, it should go at the bottom, right? And if it is larger, then it should go at the top of, right? So this method, what it tries to do is that, so first of all, right, when it is returning from here, fourth step to third step, now the number is 3, right? After this time the stack was empty, so it will just simply go and put, in the stack it will go and put 3. Okay. Then when it went from the step 3 to the step 4, the number is 4, which is more than 3, so it just put 4 here. Okay. But when I go into the step 2, the step 1, it found 1 is here, so it will put 1 in the starting. Now how it does that magic, how does it put 1 at the starting and not here, is that how we have to implement this method, insert element in order. Okay, we have to implement this method so that it does that magic. Okay, so far so good. Are you guys with me? Is it clear whatever that I'm saying, or not? I'll repeat it.
Yeah, so please repeat once.
Okay, what I'll do is that in the next I'll just give an array, suppose 3, 2, and 1. Okay, and suppose we divide into the 3 sections. So this is a dry run. This function 2. The first function that I have defined is void, and then suppose sort. Okay, and this takes stack S. Okay, first condition is S is equals to null, or S is empty. In that case, return. Don't do anything. Okay, this is clear. And after that, what I do, I get data int. Okay, and what I do is that I do sort. I do this, and then I call a function insert in order, and I pass S and I pass data. This is my first method. Okay, let me define all the methods and then we'll dry run and see. Okay, now this method is void. Okay, it takes S and it takes data. Okay, this method is if S is empty or S dot peak is less than equal to data. In that case, I simply do and put S dot push data. Okay. If that is not the case, what I do is that I again pop this and data is equal to s dot pop, and what I try to do is that insert data one. So this is data one. Insert in, I put s and I pass again the same data, and then I do s push data. Okay. So let's first try to understand this method try run. Okay. Let's try to first understand this. Suppose my stack right now is this. It's not different from this question. So suppose my stack right now is say 4 and suppose 1. Suppose my stack right now, initial case 1, then my stack is equal to empty. Okay. So in this case, when I call, insert in order and I pass s and I say pass 5. So what will happen when the call happens? It will hit this if, right? Because stat is empty. So it will end up doing s dot push 5 would have become 5, right? I'm just trying to write on this function too. Okay, I'm trying to write on this function too. Initially, suppose stack is empty and I want to insert 5 in order, then it went right. Now, suppose the case 2, let's try to take the case 2. In that case, now I'm trying to insert again, insert in order, say s and say 1 in this case. Okay. So what happens is that now the stack is not empty, it is already having the 5 element in it, right? So this if block will not get, so first time when it goes inside, right, the value of the stack is 5 and data is, so if condition doesn't get satisfied and data 1 value comes out to be 5, right, because this is what we are doing here in this state, data 1 equals to 5, and we again recursively call. So again recursively step 2 will get called, and when the second step call, the stat s will now is now empty, right, and data is still 1. So again it comes inside the if block and it hits the empty part. So what it does is that it enters that. So it enters 1 into that. So now the s becomes 1 and it returns, right? So when it returns, it comes back to the step 1. When it comes back to the step 1, the s is now holding data at this step. It comes back to this after this step. S right now is holding 1 data, and I am now pushing the data 1 here. I'm pushing on the data 1 here. So data 1 is 5 here. So this inserts 5 here. So basically this method, what it is trying to do is that it is trying to put the data at the right position. Basically smallest element at the bottom and the larger element at the top. This is how it is doing. Is it making sense?
Yes, sir.
Okay. So now what is happening is that if you see in this code, right, in this code, we haven't given a stack. Suppose the stack is 3, 2, 1. Okay. So this part is just a boundary condition check. So if I have to dry run this whole method, right? So function 1 ko agar apan dry run karenge, okay? So the first time when the method is getting called, that time the stack value was 3, 2, and 1. Okay. And inside that the data value that came was first 1. Okay. And then what happened, the second recursive call happened. At that time the value of the stack came out as 3 and 2, and the data value became equals to 2. And then third time when it went, it is s equals to 3, right, and data value came out as 3, right, and then the fourth time s got empty, and that what I have to do, I have to return back, right, I have to return back. So this is where the recursion comes back in the step 3. Now when it comes back to the step 3, at this moment what it does, it makes a call to this function insert in the order, right? So when it makes a call to this function, at that time the value of the stack is empty and it has to insert, what is do, it has to insert 3 into it, right? So when I call this function insert in order, what it will do, it will insert 3 into this simply because this the stack is already empty. So it will just, our final stack that is in this, the 3 has got entered. Okay. After that again I go back to the step 2. In the step 2 the value of data that has to be entered is 2, and the stack right now I have is 3. So I again call this method. Okay. So in this method now the stack that I'm passing is having 3 already, and I have to add 2 in it, right? But what this method do, it does, insert the element in the order, right? So what it will do, it will convert the the array into like this. So it will do first 2 and then it will put 3. So now stack is this. Now when I again go back to the first step, again now I have to insert 1, right? And at that time the stack is having 2 elements, 2 and the 3. It will again, from here I will call this function again, and now it will again insert 1 in the order. So it will now convert that into 1, 2 and the 3. So this is how the array will get sorted using recursion. So basically we are using recursion on the 2 different functions, and we are combining that into the one. So this is again a very classic example of a recursion which can be used to sort the stack.